energy, right? Can someone tell me?
Moving energy.
Moving energy, so when we see something moving, right? What about potential energy? What's potential energy?
Stored. Energy that is stored.
Stored, so when we're holding something, it'll become kinetic energy?
Yes.
Yeah.
Can someone give me an example? Happens? We've
A
talked
chair
about-
moving.
Can someone give me an example of when that happens? We've
A
talked
chair moving.
about chair moving?
Like you can be sitting on a
Like a
chair.
rock? So, where's the potential energy in that? To start. Angela?
Like when you're holding it, that has potential energy. Like that.
So when you're holding it and then you let it go, so if you're holding a rock, you're storing all that energy, so that's your potential, right?
Yeah.
That's
And
your
when you let it
maximum
go.
potential energy, and then you drop it, and then what? What happens when you
Kinetic.
drop it?
It moves.
Kinetic energy, right. So now we're going to open up to our proof. And so I want you guys to write the true definitions of kinetic energy. I want you guys to write all this, and it shows you this diagram over here is where you can see this claw is holding that ball. So that's that potential energy that's storing up. And then you let it go, and as soon as it's letting go, you're getting your maximum kinetic energy. But when it's up here, that's your maximum potential energy. When it's being held by that claw, that's your maximum potential energy. That's when it has its most potential energy at that height. So do you think is kinetic energy so after what I just told you, where is kinetic energy the greatest when it's falling? So as it's falling, it's gaining kinetic energy, right? So
So
as
it's
it's
at the
falling,
bottom?
At the top.
so that's potential, but
At the
as-
bottom.
at the bottom, but
Once it hits.
right before it hits.
As it's falling.
Yeah, so as it's falling, and as right before it hits the floor, that's your maximum kinetic energy. So do you think the height that you dropped it at would change the kinetic energy at all?
No.
Ms. Lancaster was saying that she saw a video about Mythbusters and whether you drop something, like if you dropped a penny from a building, would it kill someone because it just... What they found out is when you dropped it from that building is that it reached its maximum and it didn't keep getting faster and faster because it had a maximum that it reached. So yes, it would hurt if it hit you from the very top of the building, but it wouldn't kill you because it would reach a maximum amount.
Wasn't it 64?
I don't know
I
the
think it
exact
was
amount
64.
that it would be,
I watched
the
it.
kinetic energy. Do you have everything written down? Then please write it. And then I'll let you go. Does anyone have any questions on kinetic or potential energy?
Do you write the potential energy as well?
Yes. I want you to write everything that's up here. So, if an object is moving, it is said to have kinetic energy. Maximum, which is KE, maximum kinetic energy is the position at which the object is moving the fastest. So we abbreviate kinetic energy with KE. And then potential energy is abbreviated with PE. So if you see me writing KE, it means kinetic energy. If you see me writing PE, it means potential energy. So potential energy is energy that is stored because of the position and or arrangement of the object. So where I hold my rock up in the air changes my potential energy. So if I were to start lower, it would change my potential energy. If I start higher, it would change the potential energy. Maximum potential energy is the position where the object has the most stored energy. So it's going to be at the highest point that I hold it. Alright, so now we're putting away our notebooks and we are taking out that lab sheet that Miss Lancaster gave you.
Which one?
The one that she handed out with the tennis balls at the top. Do we need to be talking when we're putting it away? Ladies. Alright. So now we are writing in the law of conservation of energy at the top box that you have. So I want to see pencils writing, please. So energy is not created or destroyed, instead it changes form. Kind of like how we talked about matter. It is not created or destroyed, it just changes form. Yeah, I definitely do.
Class, this is 3 or 4, right?
Oh. So you guys are writing in the definition of the law of conservation of energy. Yes, Caleb. Do you have your slow card? So an example that we have up here is when we have chemical energy changed into mechanical energy. So when we're eating food, that's chemical, and then when we use that energy, it becomes mechanical. So when you digest, you're taking in all those yummy nutrients, and then it's becoming mechanical. So that's all that chemical energy, and then you're using that energy that you stored up to become mechanical, because mechanical gives you all that energy to move around. And then also, what we've been talking about, potential energy can change form into kinetic energy. All right. Wait, no. Can you get it from your neighbor? Yeah. All right. So now we're writing our testable question for this lab. Can anyone? So if we in this lab, we're having a tennis ball. So yeah, so write does and then effect, and then we're gonna fill in this sentence.
On the line?
Yep, on the line, the testable. Yep, on the line, the testable question. So if you're in Enrich, you've done this a lot in Miss Lancaster's Enrich. So in this lab, we're gonna use a meter stick, and we're gonna have a tennis ball. And we're going to see if where I drop it from affects how it bounces back up. So when I drop it, I'm going to see where it bounces back up to. And I'm going to see, we're going to test different heights of where we drop it from. And we're going to see how that affects the height that it bounces back up to. So from what I just told you, what would you say, how would we write our testable question? What are we asking?
How high the ball bounces?
So yeah, so how much does the ball bounce back upward? So does
The height matter.
the height of the
ball
the drop height, does the drop height
affect the ball's bounce?
does the drop height, so the height at which we drop the ball, does the drop height affect what?
The way it bounces back up.
So the height, the bounce height, right? Let me know if you can't read my handwriting. Sometimes I'm not the neatest. I try. So then, can anyone tell me what our dependent variable is? What are we testing?
The ball.
Yeah.
How high?
So we're dropping it, right? So it's what's being measured, right? What are we measuring? at what? Which height? So I have my drop height, the height that bounces back. So our dependent variable is the bounce height. So we're testing to see how much it bounces back. So do something once, they do it multiple times.
I'm not getting ready to hit you.
What?
Let's get ready to hit you.
That one didn't really work. So what are you guys doing? I don't see any numbers written on the table. I know, but you should write it once. Is that your, no? You have to write it every time.
I didn't do it.
Oh!
I did it. No, I didn't.
Look at the end of the thing.
No, you didn't. 43. Okay, then write, where would you write 43?
It's right here.
That, no, you just not. And make sure when you guys change your heights, notice what happens to the bounce height.
Miss, can we
Miss Lancaster can use their phone. You can use your phones to get the average. But if I see your phones being used for anything else, you have to put them away.
7 inches.
No, I didn't. That's definitely. Right, right,
33.
Did you guys?
Wait, what
Why did you turn us 70?
That's 100. See, it was 90. And then once you guys are done, I'm going to take one of your guys' data tables and I'm going to put it up here, so I better see everyone's data table filled out.
Miss, what do we do with the ball?
When you're done, you put it back in the bin.
That doesn't mean I want you guys to stop. Anyone see a leaf kind of fall around that? You guys lost the tennis ball. Ow!
No, we didn't make
We'll find it after everyone's you.
No, that's at the very top.
Can you stop?